If we look at this visualization of what it actually takes to build a C++ compiler from scratch, you're looking at four massive pillars of requirements. We have to map out thousands of distinct keywords, define intricate grammar rules, build robust error-handling protocols, and write incredibly complex optimization algorithms. Writing the code to handle all of those thousands of rules entirely by hand is a staggering undertaking. It would demand years of grueling labor from a team of developers and inevitably introduce a massive margin for human error into the system. Think of it like constructing a house. If you had to manually forge your own steel beams and mix your own cement from raw materials, finishing the job would be nearly impossible. But if you bring in ready-made industrial machines, the work scales instantly. In software engineering, compiler construction tools are the equivalent of those industrial machines. They are specialized pieces of software designed explicitly to generate these complex compiler components automatically. This means we are essentially using software to write the software that translates our code. This meta-programming approach is the foundational strategy behind all modern compiler development. When raw source code first enters an automated compiler system, it arrives as a continuous, unstructured block of text. To make sense of it, the system needs a scanner to read through the characters sequentially. Instead of hand-coding that scanner, developers rely on LEX. LEX stands for Lexical Analyzer Generator, and its primary job is to automatically write the exact code needed for the scanning phase. Developers feed simple, regular expressions into the central LEX hub. The tool transforms that expression into a functional node-and-wire state machine. As raw text flows through, the machine actively processes it, outputting discrete, standardized token blocks, acting as an automated tokenizer. Once those tokens are generated, the second crucial step takes over. This is where we bring in YACC, which stands for Yet Another Compiler. We feed context-free grammar rules directly into the YACC hub, defining the programming language's structure. YACC generates a parser program. When fed a simple equation like A equals B plus C, it automatically builds a hierarchical branching syntax tree. By combining LEX and YACC, developers avoid writing complex text processing algorithms entirely. They write a few structural rules, and the tools automatically generate the entire front-end syntax validation for the compiler. Syntax checking is just the first hurdle. The remaining phases of the compiler pipeline also require their own specialized generation tools. To handle the actual meaning of the code, we use a syntax-directed translation engine. This tool automates the semantic routines, ensuring that the variables make sense by performing automatic type checking. Next, we move to optimization. In this data flow visualization, the data flow analysis engine scans a sequence of variables. It isolates redundant operations and identifies dead code, code that doesn't affect the final program, and automatically deletes them from the chain to maximize efficiency. Finally, the code generator takes the refined intermediate code, pairs it with the specific hardware descriptions of the target machine, and translates it all into the final executable assembly code. Every complex phase of the translation process has a dedicated automation tool. Together, they interlock to form a complete end-to-end assembly line. This matrix maps the 5 compiler phases to their automated tools, like LEX and YACC. Tracing an equation through this flowchart, it passes the LEX node to become tokens, then into the YACC node, forming a parse tree. It is critical to note that these tools do not act as the compiler themselves. They are the software that generates the specific components that will eventually make up the compiler. By utilizing this automated architecture, developers can build incredibly complex and reliable compilers at speeds and levels of technical consistency that manual hand-coding could never achieve. Now that we understand the toolset, we can finally dive into the exact mechanics of that very first phase, lexical analysis. Mastering how we automate the start of the pipeline establishes the technical foundation for everything that follows in compiler theory.